Hello guys and welcome back to another video. Today we are going to be taking a look at a really new topic which came during the reInvent of 2022, which is EventBridge Pipes. So I started playing around with this tool very recently and I figured out that it was quite powerful than what people think it really is. So that's why I decided to make this video today to provide you all a really quick crash course on EventBridge Pipes and how you can leverage its full potential and develop awesome new stuff with it. So the whole point of this video is to just talk to you about how we build AWS applications currently. And then we are going to be talking about how we can move that process onto EventBridge pipes. And finally, we're going to be taking a look at a really quick demonstration on how EventBridge pipes work and how you can get started with it. So when we first talk about how we build AWS applications, it's just about integrating several components together. So you can think of AWS as a bunch of features or a bunch of services which act like Lego. So you take these independent services and you integrate them or you connect them like building blocks and you build awesome applications in the cloud. Now, when you have all of these pre-built services that you can just build and you can just integrate together, you don't have to worry about managing data centers or spinning up infrastructure. You can directly focus on how you can add business value to your product. And when you talk about such building blocks, a few common building blocks that we see or how we particularly interact with in the serverless space is these four, or you can add a few more stuff, but these are some of the few services that you might be interacting with on a day-to-day basis if you're a huge fan of serverless. So the very first one is DynamoDB. So if you want a really high performing non-relational database which offers around single digit millisecond latency, DynamoDB is the way to go. And if you also want, let's say, a really powerful event-driven compute service, you can have AWS Lambda. And if you want to take it one step further and you have really high demanding workloads where you just want to ease the load on your backend and your rest of your architecture, you can adopt a queue to just streamline the flow and just allow your components to scale independently and on an orderly basis. And next, if you want unlimited data with really fast access on the cloud, S3 is another building block that you can use to build full-fledged software. And if you once you take all of these services together and once you start building it, you can build applications like this. So for example, here we have a simple backend API which uses DynamoDB way to persist data or get persist data most likely. And from there, we have a stream event from DynamoDB, which again invokes a Lambda function to process the stream records. And then it will push the data onto SQS where it can be processed again separately, or you can have it on SageMaker if you want to like process it on an AI model or something. So when you connect these dots and build use these building blocks to build such applications, you get pretty limitless capabilities on how you model your application. But there are certain issues when you take a look at these point-to-point integrations. Now, for example, you have to write ton of code to integrate. If you take a look at the diagram below now, to integrate between a DynamoDB table and a Lambda function, you have to integrate a stream event subscription. You have to have an event source for the stream and for the stream where you can process the records. So that takes up a lot more effort from the developer's perspective, where you have to think about the complexity of the code, and you also have to think about how these services communicate. Like when you talk about DynamoDB streams, you have to talk about the batch size. If you were thinking about something like SQS with Lambda, you'd have to think about the event source subscription, and then you have to talk about batching and how you're going to handle errors and so on and so forth. So it's important that you understand how these point-to-point integrations work. And if you want to build a very ordered fashion where you want to ensure that the data goes in the same order that it enters into your source, you have to implement that also. And next, you have to think about your end consumer, your target. You have to think about what authentication does it need. And if you are, let's say you are integrating a Lambda function which communicates with an end API, with an API that is outside of your AWS account or with another API gateway. So then you have to think about how it's going to authenticate, whether it uses an API key or whether it uses basic auth or an open ID connect or something like that. So you have to think about that as well. And also you have to think about rate limiting and throttling and so on and so forth. And then you'd have to deploy this integration and you have to monitor it to ensure that it scales well and you don't have any bottlenecks over there. Now, this is where EventBridge Pipes comes into the picture. Essentially, EventBridge Pipes is just a point-to-point integration service where it allows you to combine or integrate a source and a target with no code whatsoever, with little to no code. As far as I have tried it, it's no code for me. Still, I have not touched or written a single line of code when I'm integrating a source and a target. And plus, AWS allows you to pick from a variety of different event sources which emit events such as SQS, Kinesis, DynamoDB, Amazon MQ if you want to have like a broker or something. And for targets, AWS has a plenty of targets where you have about, I think, 14 different targets where you can push your data onto EventBridge. From there, you could set up event rules which have another targets, and you could just fan out your load from there. You could have step functions if you want to create a state managed workflow, and you could pass it to a third party API or a different queue. And also, these pipes, not only do they allow you to just integrate two services together, it also helps you figure out when you want to pass data to a target. So it helps you filter out data and only let the stuff that you really want to go to the target. So this, in a way, it helps you make your function more efficient or your target more efficient. And also, it allows you to enrich your data or perform any additional computation to it to format its shape before sending it to the target. So in that manner, it's essentially, you could call it on the verge of a low code tool that allows you to perform point to point integrations with little to no code at all. Now, some of its key features, it allows you to filter events. Like I said, it allows you to send data to the target based on a criteria, that's if you want, and it allows you to batch events based on the event source, and it allows you to order it. And it also has high concurrency, meaning that EventBridge Pipes takes care of the scaling on the integration between the two services. So you don't have to worry about that. And it also allows you to perform advanced enrichment to your data. So the data you get from the source might not be the exact shape that your target requires. So event-based pipes allows you to add a middle layer or a pipe or another filter mechanism or a pipe and filter mechanism there, where you can enrich your data and transform its shape before sending it to the target for consumption. And because of this, it brings about a lot of benefits. So some of the benefits that I feel is because it saves a lot of integration code, because you don't have to worry about which parameters you want, what kind of factors to consider, and the overall complexity of the code to integrate these two services are gone now. And because you filter and send only the data you want to the consumer or the target, you save costs from the target's perspective. For example, let's say in a Lambda function which takes in data from an API gateway. Okay, no, let's refresh it. So if you want to take data from, let's say, a DynamoDB stream onto a Lambda function, let's say that you don't, in your Lambda function, you have implemented a validation where you only want to handle the events which have the modified state on it. So only if the data is modified from the DynamoDB stream, if the stream has a modified item, only you process it. Now, previously what we used to do was we used to have the validation in the Lambda function itself. Now, what this meant was your Lambda function was invoked even if you didn't want to process anything. So even if it was an insert event, your Lambda function still invoked because of the stream. But with pipes, you could set up a filter mechanism to push data onto the target only if the event type is modified. And also it reduces your overall operational load because you don't have to worry about your infrastructure or your point-to-point integrations. You can directly let EventBridge pipes handle it. So with a basic understanding of EventBridge pipes, I think now it's quite important to understand when you should use these pipes. So first of all, if you want to just connect two services together with little to no additional code, so the best case is if you want to connect a DynamoDB stream to a Lambda function, or if you want to have an SQS queue which pulls data from Lambda function, you don't have to worry about creating the event source subscription and the batching window and batching sizes and everything, or handling partial errors. You can just let EventBridge pipes take care of that by just having just a point-to-point integration, where you just go to the EventBridge pipe in the AWS console and you just select your source and your destination and you just click create pipe, and that will provision everything that you need. Next, if you want to filter records, so let's say you have your DynamoDB stream which emits data which you want to process in a different manner. You want to process your insert events in a different way and your modified events in a different way. So for that, you could set up two pipes on your DynamoDB stream. And I also personally recommend maximum of two consumers from your DynamoDB stream, because it affects the overall read capacity on your DynamoDB table. So with that, you could set up two EventBridge pipes, where the first pipe would filter out the insert events and the second pipe would filter out the modified events, and just push it onto that consumer. So with that, I think that's all that you have to learn about pipes. But I feel like there are a few points that you should also understand when you have IAM. When you talk about IAM policies, EventBridge pipes already takes care of that behind the scenes. So for example, if you were integrating an SQS and a Lambda function, the EventBridge pipe would automatically detect the roles, the permissions that you need, and create a role with the minimum permission set. So that way you're also good to go. And if you were, let's say, if you had to perform any additional enrichment, you could set up an API connection or another Lambda function or a step function workflow and perform that enrichment and just push it onto your consumer again, for your target to consume. So with that in mind, let's take a simple example and just create an EventBridge pipe and just take a look at how it works in a production ready application. I'll see you in the AWS console. So in this part of the video, we are going to be getting our hands dirty and we are going to be implementing an EventBridge pipe. So in particular, we are going to be taking a look at a simple use case where we are going to be connecting a DynamoDB stream and a Lambda function together using an EventBridge pipe. So first things first, let's head on to our AWS console and let's just start provisioning the infrastructure, the resources that we need. So first of all, we would need a DynamoDB table. So for that, let's head on to our DynamoDB console and let's create a new table. So let's create a new table and we'll just call it the order table because we're going to be processing an order here. So for that, we'll have the order ID. And yeah, we'll just put this on demand. And yeah, we're good to go. We'll just create the table and let that provision. And after it provisions, we're going to need to turn on the AWS or the DynamoDB table streams, because we need to actually have a stream in order to create the EventBridge pipe, because it's going to be taking in the events from the stream and then processing that in a one-on-one order and just pushing it onto the consumer. So one thing to note about these pipes is, guys, you have a single source and a single consumer. So pipe cannot directly have different targets, unlike EventBridge rules, where you can set up an EventBridge rule and have 5 targets. In pipes, you have one source and one consumer. Now that consumer on its own could push data to different sources. For example, you could have an SQS queue which has about 5 other consumers. We could push it to an SNS topic or another EventBridge rule or an EventBridge bus. So something like that, you could do that and create. But by default, EventBridge pipes has only one source to one consumer. So yeah, let's just go to our DynamoDB table and turn on streams. Yeah, capture item level. Okay, so just turn streams on, and we are gonna have new and old images on our stream. So that means we're gonna have the old version of the item and the new version. So yeah. Okay, that's awesome. So now we have the stream, and let's go set up a Lambda function to process our stream. That's going to be processing our stream record. So for that, we're going to go to our AWS console on the Lambda console. And we're going to be creating a function, and we're going to have it a stream processing function. We'll just call it order stream processing function. And yeah, that's good to go. We can have it on node. Yeah, okay. And we'll let that provision. It'll create the IAM role and everything. So it'll take a few seconds. And after it's done, we'll just update the code a bit and make this console log everything so that we know what we are going to be getting. So for that, we'll just go to the code and let's just edit the code. And yeah, let's just console log the event and deploy that. Okay, that's awesome. And then let's head over to EventBridge. So when you get over to EventBridge, you'll see a new section called pipes. So that's where we're going to be doing our business. So here, EventBridge pipe, a pipe connects an event source to a target with optional filtering and enrichment. So we're going to be creating a pipe. You can create it through here, but we'll just go to this part. So you can see all the pipes that you have. So currently, I don't have any pipes in my AWS account or in this region. So we'll just go and create a new pipe. So source, the source is where we're going to be getting our data from. So obviously we're going to be getting it from a DynamoDB stream, and we are going to get it from the order table. And we are going to be getting this stream starting position. So usually when you do this, you have to define this in your code, but here EventBridge Pipe allows you to do this with just minimal effort. So we're going to be getting the latest records from the stream, and you have additional records. So here you have batch size, the batching window, the concurrent batches per shard, and on partial. So here how you're going to be handling partial failures. So if you have 100 items in the batch, if one fails, what are you going to do? So they are going to let you handle all that. So these are the stuff that you used to have to implement manually through your code. But now all of that is being taken away from the developer, and the developer just has to work on the console and just give a few commands and they're good to go. So for this, we'll just leave it in the by default settings. And if you go to pipe settings, you can also check EventBridge needs a permission. So here, this is where I mentioned it creates the role and assigns the policies which are needed for the minimum permission set. And here it also has a retry policy. So EventBridge attempts to retry failed notifications by default 24 hours. So you can have that. You can have a dead letter queue. So if the records fail from the stream, you can directly push that onto a dead letter queue. So that's error handling coming to help us. So if you have around, let's say, partial failures, you can push that onto a queue, a dead letter queue, and you could start a DLQ redrive back to the source, or you could just process it in the dead letter and just flag it as an error or something and notify someone that this error has occurred. So that's something that you can do. But for now, we'll just get rid of filtering. So we can add that later on. So yeah, so this is a sample filtering on how it'll look like. So here what's some stuff that you can do. So here there are sample events that you can take, and here are the sample event patterns. So yeah, we're gonna get rid of the filters and we don't need enrichment at the moment. For now, we're just going to create a point-to-point integration. We are going to be hitting that to a lambda. The lambda on would be the order processing lambda function and invocation type. It will also ask how you want to do it. If you want to do it to a fire and forget or to a synchronous. So you can choose that based on your requirements. So I'll just create an asynchronous flow where it'll just fire it and forget it. So yeah, so after that, we can just create the pipe. Okay, I think should be creating now. Did I miss a step? No, all good. Okay. Okay, all good. Okay, we just set it to request response. Okay, why isn't the pipe creating? Ah, okay. So we'll just leave this on our fire and forget. So it seems that we have not named our pipe. So we'll just call this stream lambda integration pipe. So order table. Okay, and then we'll just create the pipe. So while that's creating, so this will take a bit of time because it has to provision the IAM role and then it has to create the actual integration itself. So behind the scene, it does a lot of stuff. So if you want, you can go ahead and monitor, you can open up the service role that it uses and just check what are the permissions that it uses. So you can see that it only uses the permissions that it needs. So let's just have an inspection on what it actually does. Okay, so let's just wait until that. Okay, so here we go. So here, first of all, you can see that it allows you to describe the stream, get the records of the stream, and list the streams. So that's one thing. And then it would just allow you to invoke the function, allow the Lambda to invoke the function. So that's it. And if you have any trust relationships, say it allows the pipe to assume the role. So yeah, so all of that is being handled. So now we can head over to our DynamoDB table and let's just enter a record and see what will happen. So ideally, when we hit this, our target should actually get a response. So here for now, we'll just go to this. Okay, now we'll go to our table and we'll enter an order. So we'll enter a new item onto the table. So let's just create an item. So order ID, it's a string. So it'll be order 1. So just have that. And let's just add a new attribute. We'll call it string. Order 4, I'll just call it Lakindu's business. Okay. So now we'll just create the item and see what will happen. Okay. So now we have the item. So now if we refresh it, it'll be there. So now ideally, if we go to this CloudWatch from here, we can see the record. So ideally, it should have executed. So let's just go to CloudWatch and take a look at the logs. Let's just see if we can have any data here, if there's any data collected here still. Okay, so nothing from metrics at the moment. So yeah, here's the stream record here. So if we just open that, we'll be able to see the event ID. So yeah, it's an event name is insert. And then we have the DynamoDB, approximate create time, keys, the new image. So we have everything. So that's pretty cool, right? So now we have created a point-to-point integration with no effort at all. But now let's take this a step further. Let's add a filter policy also. So now what we'll do is we'll go to Lambda and create another function where this will only hit on order. So we'll call this order stream. And for this, we have to call this the modify detect. So this will only run when there's an update on it. So only when there's an update on the event name. So for that, let's just let the Lambda provision. And after that, we'll go to our EventBridge again. And we create another pipe. So let's just copy this name. So we'll need to have a source. So we'll have a DynamoDB stream again. And now we'll have a filter mechanism here where we will filter it through the event name. So for this, so we need the data here. So if I'm not mistaken, it's data. And then we need to get this event name. And that should be update. It should be, if it is update, you should be able to test the pattern. So let's just test it and see. Okay, sequence simple event. So if we have this as update here, let's just copy this and enter my own. And let's just test this and see if it's all good. It's actually not, it's not update, it's actually modify. And I had read the JSON payload wrong here. So the correct event pattern would be this. So where if we have this pattern, so it will only work on where the event name is of modify. So if we just test the pattern now, it'll actually see the sample event match the pattern. So now if we go and create this, so here we'll call this the modify order stream pipe. And do we need any enrichment? No, not at the moment. So let's just have the target. And let's send this to another Lambda function where we are going to send it this time to the modify detect, and we're going to call this fire and forget again, and we're going to create the pipe this time. So now once we let that connect, if we actually go to our Lambda functions now, so I'll just close all of this, and let's say the pipe is created. So the pipe is still creating. So if we go to our order table and if we add a new item, so let's just add a new item again just to check how it works. So let's see if the pipe is, yeah, the pipe is now provisioned, I think. Yeah, the pipe is good to go. It's okay, it's still creating. Okay, now it's running. Yeah, all good. So now if we go and create an item, and if we call this order 2, and we'll add a string here, order 4, this will be your business. So if you go and save this now you might, if you go to our Lambda functions, so if you have the 2 Lambda functions now, we can go and check the CloudWatch logs here. So the order stream processing function will work, but this won't be executed, the modify detect. So let's check the modify detect logs also, and let's open up the logs for this. So let's go to the modify Lambda logs. Okay, the modify Lambda logs. So this is for modify detect. So it says the log group does not exist here. So that means this Lambda has not been invoked yet. And if you go to the order stream processing, that has created a record here. It has executed and it has given us the order for the insert now. And now if you go ahead and update one of these items, so let's just go ahead and call this, nope, this was an update. And if we save the settings, and if you reload this, it'll have updated, okay. And if we go back and go to our order stream processing Lambda again, and if we just refresh the log events, this will actually have another log event because we did not have a filter on it. So this will run anytime it wants. So now it says the event name is modified. So that's correct. That's what we wanted because this has no filter on it. But now you can see that this one would actually have an event on it. So this Lambda would actually be executed and it would have generated a CloudWatch record for us. Awesome. So here's our log record. So yeah, so that's what we can see. So here's we didn't have any console log on it. So this is just an invocation. So yeah, so that shows that this works as intended and it's a pretty powerful tool. So now you just saw that we integrated a DynamoDB stream with a Lambda function. And we set up a filter policy also with little to no code actually. If you took a look at the process, there was no code at all. It was basically low code to no code platform to enable point-to-point integration. So I highly recommend you check this tool out and try to incorporate in your workloads. Do let me know if you run into any issues integrating this service in your application. I'd be happy to help you out. And until then, I hope you enjoy the rest of the videos on our channel.